Hello class, and welcome back to Unit 1, Graphs of Linear Functions. So in the first video, we graphed linear functions in two ways. In the second video, we wrote the equation of a linear function given the graph of a line. And in this video, we're going to write the equations of lines parallel or perpendicular to given lines. I'm also going to talk to you a little bit about horizontal and vertical lines. So let's start with horizontal lines. So horizontal lines are lines that are like the horizon. So that means that they go straight across the page like this. This would be the example of a horizontal line. Horizontal lines have the equation f of x is equal to c, where c is any real number. So you can think of a horizontal line as having a constant output. Horizontal lines have a constant output. So no matter what value you have for an input, no matter what value x takes on, the output remains the same. That's why you sometimes hear these functions called the constant function. So I've sometimes seen this described in textbooks as the constant function. Because the output is always constant. So let's do a little example. Let's say we have f of x is equal to 3. If I were trying to graph this by plotting points, here's kind of what my table would look like. So I have x and f of x. So when x is -2, f of x is 3. When x is -1, f of x is 3. When x is 7, f of x is 3. No matter what value I choose for x here, I'm going to get the same output every time. And so then when I graph this function, I'm going to go to the output of 3, and it's just going to be a straight line all the way across. So here's my x-axis, and here's my y-axis. And this is our line, f of x is equal to 3, and that's a horizontal line. Notice here too, our x-axis is also a horizontal line. So that's horizontal lines. Let's talk vertical lines. Those are the lines that go straight up and down. So their equations look like this. The input is a constant value. The input value of x is equal to c. So we would say that in this case, instead of the output being the same, the input is constant, while the output changes. So if I were to give you an example here, and I would say x is equal to -1, and we wanted to graph that line. So we wanted x and y values. Well, x is -1, and y here can change. Y can be anything. So y could be 0. Y could be 1. Y could be 2. Y could be 100. right? As long as x is equal to -1, y can take on any value. And so let me show you what that looks like here. Here's our x-axis, and here's our y-axis. And so at the value x is equal to -1, I'll have a vertical line straight up and down. And that'll be x is equal to -1. So this would be our vertical line. I want to talk a little bit about the slope, the slopes of vertical and horizontal lines. So let's suppose we have the horizontal line that we used for our first example. F of x equals 3 is horizontal. And we know that the graph looks like so. Here's our x and y axes. There's our x and there's our y. And we have this line here, f of x is equal to 3. I'll highlight it so that you can see it really well. It can be very clear. So this is our line, f of x is equal to 3. And we want to think about what's the slope of this line. Remember always that your slope is the change in your vertical direction, the change in your y values, divided by the change in your x values. And in this case, we're not changing vertically at all. The y value is never changing. The y value is constant. It's always 3. So we end up with 0 divided by the change in x. And what that means for us is that 0 divided by anything is equal to 0. So the slope, this will be actually true of all horizontal lines. Is 0. So the slope of all horizontal lines will be 0. Let's talk about the slope of a vertical line. So let's use our example of a vertical line that we did before. So we said x is equal to -1 is a vertical line. And if we were to graph it, just like how we did in our example, so here's my lovely graph, my x-axis, my y-axis, and here's my line, x is equal to -1. And I'll highlight that again just so it's kind of clear what we're talking about. This is our line, x is equal to -1. So again, we're going to use this definition of slope. That slope is equal to our vertical change, our change in y, divided by our horizontal change, our change in x. Notice though, in this situation, our x, our input, is constant. It's always equal to -1. So there is no change in the x value. So we end up with delta y divided by 0. And this should make your mathematical heart cry out. We cannot divide by 0. Dividing by 0 gives us an answer that is undefined. And we will talk about this when we meet in person. We will talk about this when we meet in person. But for now, I want you to just know that the slope of any vertical line is undefined. So that's a little bit about horizontal lines and vertical lines. I'd expect you to recognize them if you saw them in a graph. I'd expect you to be able to write the equation of one, things like that. But I actually wanted to talk about them before we talked about parallel and perpendicular lines, because horizontal and vertical lines can teach us something about parallel and perpendicular. So I'll mention that in a minute. So let's start off. We're going to kind of switch topics for a minute, but I promise we're going to talk about horizontal and vertical in this next part as well. So let's start with parallel lines. So the definition for parallel lines are that parallel lines never intersect. And I mean never. Let me give you an example. I'm going to draw us a beautiful X and Y axis here. Trying to channel Bob Ross when I tell you guys that. Our beautiful X and Y axis. I hope these videos are not too tough, a little relaxing. I hope you take notes, rewind when you need to, pause when you need to, have your snack, have your coffee and tea. You're just trying to absorb a little info, okay? You'll have plenty of time to ask me questions in class. Just write some notes, try to learn stuff. You'll be all right. So here we have, I'm going to have our example of parallel lines. You ready? So here's our first line that I'm going to give us. Oops, that was bad. I'm trying so hard to draw neatly for you guys because I know it helps, but it's not my strong suit. It's something I need practice with. So here's one line that we're going to have. And here is our second line that we're going to have. Oy. I'm trying so hard to make it beautiful, you guys. But again, like Bob Ross would say, it's beautiful because I made it. My beautiful lines. So you can see here, these lines are never going to intersect. That's what makes them parallel. They're never going to touch each other, these two lines here. The distance in between them at each point is staying exactly the same. They're not getting any closer together. They're staying the same distance apart. Parallel lines actually have the same slope. The same slope. So you can see for this line I'm highlighting in blue, the equation of that line is f of x is equal to 3x plus 3 and this line that I'm highlighting in green, the equation of that line is g of x is equal to 3x minus 1. And so here we have a slope of 3. They have the same slope, and that's what ensures that they are going to be parallel. Parallel lines have the same slope, but they have different y-intercepts. They have different y-intercepts. So let's talk about perpendicular lines. Perpendicular lines intersect. And when they intersect at a 90-degree angle. So one example of a 90-degree angle that we've seen a lot in math and that we will continue to see a lot of in this course, is actually the x and y axis. So when the x and y axis intersect here at this 90-degree angle, what that means is that when they intersect, they have this 90-degree angle right here. Perpendicular lines, when they intersect, they divide the space up into 4 different quadrants, like that. So the x and the y axis are perpendicular lines. Let's do another example of perpendicular lines here. So I'm going to draw a set, but first I'm going to move my x-axis so that, or my x and y-axis, so that it's perfectly lined up with my graph paper. Otherwise it's going to bother me. Maybe it'll bother you too. There. Oh, doesn't it look so much better? I keep asking like you're going to answer me in the video. Comment below if it looks so much better once you line up the graph with the graph paper a little bit. So I'm going to give us an example of perpendicular lines. I'm just going to sketch this line really quickly here. And I'm giving myself a lot of points to draw through so that I can get a nice straight line with the power of technology. So here's our first line. Let's call this line 1. And I will draw intersecting perpendicular line to line 1. Give myself lots of points once again so that the power of technology can give me a nice straight line. So these two lines, we'll call this one line 2. These two lines are perpendicular because when they intersect at this point, they create that sharp 90-degree angle. These two lines are perpendicular. Let me show you some lines that are not perpendicular. These lines are not. So this is an example of lines that are not perpendicular. So let's draw ourselves an x and y axis here, and I'll show you two lines that are not perpendicular. Here's our y, here's our x. I'm gonna line it up a little bit, make it so beautiful. Okay, so here's the x and here's the y. And let's draw some lines that are not perpendicular. So here we'll call this line 1, and we'll call this line 2. So notice they intersect, but the angle that's formed here is not that perfect right angle. It's slanted. This is not 90 degrees. So this would not be perpendicular. So let's do a couple of quick examples just to make sure we know what's parallel and what's perpendicular. Oh, you know what? Before that, I should give you guys a better definition for perpendicular. Because you can see, looking at the graph, okay, sure, Sarah, these are perpendicular. These are not. But what about looking at the equation? So here's how we know when lines are perpendicular. Let's say F and G are two perpendicular lines. Then the slope of F is the negative reciprocal of the slope of G. So let's give you an example, and I'm actually going to give you the example of the lines that we graphed before that we were able to see as perpendicular. So let's say we have f of x is equal to 2 times x, and we have g of x is equal to negative 1/2 x plus 5/2. This was actually the example I gave you above that I graphed for us. So take a look here at our slopes. I'm going to highlight those in red. So we have a slope here of 2 and a slope here of negative 1/2. So here's what's meant by negative reciprocal. Let's call the slope of f m1 is equal to 2. And let's call the slope of g m2 is equal to negative 1/2. So then when I say I have things that are the negative reciprocal, m1 should be equal to negative 1/m2. And the vice versa. It's also true that m2 should be equal to negative 1 divided by m1. Let's plug in to see. So m1 is 2, we said. So is it true that 2 is equal to negative 1 over negative 1/2? Is that true? We could figure this out doing a little algebraic simplification. So I know that a negative divided by a negative is a positive. So this is the same as saying 1 divided by 1/2. Now, if you like, you could type that into your calculator, and that would work out just fine. You can also simplify by multiplying by 2 divided by 2. So 1 times 2 gives me 2 for my new numerator, and 1/2 times 2 gives me 1 for my new denominator. So yeah, it's actually true that m1 is equal to negative 1 divided by m2. True. And here, let's test it the other way. I said it worked both ways. So m2 should be equal to negative 1 over m1. So here, our m2 is negative 1/2, and that should be equal to negative 1 divided by m2, which is m2 here is 2. And that one's a lot easier. I see that these two are equal. Nice. This one was a lot easier. So that's how you can know these two lines are perpendicular. Another thing you can know when two lines are perpendicular, another way that you can check if two lines are perpendicular. So if f has a slope of m1 and g has a slope of m2, and if f and g are perpendicular, then m1 multiplied by m2 should give you negative 1. So let's test that out in this case. So we had a slope of 2 and a slope of negative 1/2. And when I multiply those two together, I do get negative 1. So that's how you can know those two lines are perpendicular. All right. So let's test what we've learned a little bit. Are the following pairs of lines parallel, perpendicular, or neither? So here's our first pair of lines. Let's say we have f of x is equal to negative 2x plus 6. And we have another line, f of x is equal to negative 2x minus 4. our second pair of lines, f of x is equal to 3x plus 2, and f of x is equal to 2x plus 2. And our third pair of lines, f of x is equal to 2x plus 2, and f of x is equal to negative 1/2 x plus 3. So if you'd like, for a second, you can pause the video and see if you can work these out. And then when you restart the video, I'm going to go through the answers. Okay, so for those of you who paused the video, wonderful work. We're going to check your answers. For those of you who just kept going right through, I'm going to show you the answers anyway. Make sure that you do the homework so that you get some practice with this, okay? So for our first pair, A, what we're looking at in all of these cases is we're looking at the slope of the lines. That's how we can tell parallel, perpendicular, or neither. So here I notice that we have the same slope. So same slope means that they are parallel. For B, for this pair of lines, again, I look at the slope. It's not the same. 3 and 2 are not the same. That's your math fact for today. 3 and 2 are not the same, so they can't be parallel. Can't be parallel, since 2 is not equal to 3. So we need to check to see if they're perpendicular. I'm going to check by multiplying, because if I multiply these two together and my answer is -1, then they must be perpendicular. So when I multiply 3 and 2 together, that gives me 6. So they can't be perpendicular. Sorry for my handwriting. So then the answer here is they are neither. It's not parallel, it's not perpendicular, these are neither. For A, the answer is parallel, as we discussed. And for C, those of you with solid test-taking strategies may already be guessing. We did one of each example, so these are probably perpendicular. But when I look at the slopes are not the same, so they cannot be parallel. And then when I multiply those together, 2 times -1/2, I get -1. So these are perpendicular. I hope this has been a helpful review for you. I've enjoyed making these videos. So now you should be prepared to tackle the homework on linear functions, and you should be ready to do that. So enjoy your homework, enjoy your day, stay safe, and I will see you in class.